And that controllability problem will extend to the systems that power humanoid robots.
And we haven't really had any large breakthroughs in the home in terms of automation for decades.
There's a robot in the movie Interstellar that looks like a giant walking filing cabinet. And somehow it feels more believable than robots that actually look human. Right now, companies like Tesla and Boston Dynamics are spending billions building humanoid robots, machines that can walk on two legs and move like people. And the technology is incredible. But there's a problem. The closer these robots get to looking human, the more unsettling they become. Scientists call this the uncanny valley, and it's the reason why TARS works so well. It doesn't try to look like a person at all. It's just a big rectangular machine that unfolds into smaller blocks, and that honesty in design makes it feel more trustworthy than robots that are trying to fool you into thinking they're human.
There's also the problem of ensuring that the robot doesn't fall over, cause property damage, or injure its human cohabitant.
And there's actual science behind why this works, and it reveals something important about how we should be designing machines that need to work alongside people in extreme environments. So let's talk about what Christopher Nolan's team understood about robot design that most people building AI today seem to have forgotten. The filing cabinet with personality. In Interstellar, there are two main robots you see throughout the story, and they're named TARS and Case. Both are former US Marine Corps tactical robots that were originally built for military use and later repurposed by NASA for off-world missions. And that military background helps explain their unique design. They have a relatively simple shape, which makes them more general purpose than a humanoid robot, and more useful in unfamiliar or dangerous situations. The filmmakers were very intentional about this. The director of photography said he always referred to TARS and Case as articulated machines rather than robots, because to him a robot is a machine that's impersonating a human being, and these are purely machines. They weren't built for a specific task. They were designed to be general-purpose machines that could step into a variety of roles to help their human counterparts. Our bodies are better at certain fine motor control tasks, but we're specialized for living on Earth. Interstellar's robots sacrifice that human dexterity in exchange for adaptability and durability, and they're built for conditions that humans are naturally not the best at, like operating in unstable terrain and enduring harsh environments and still being able to function after taking damage. TARS and Case have this cube-like monolithic shape and can switch between several configurations depending on the situation. They're built of 4 main pillars, each of which can unfold to reveal smaller appendages used for grabbing and carrying and stabilizing themselves. That same design allows for several types of movement, from a standard walk to a much faster rolling motion, where the robot turns itself into a sort of wheel. So instead of copying the human body, TARS and Case reflect the most important aspects of a general-purpose machine, which are balance and simplicity and reliability. And we already have plenty of examples of generalized robots not built for human spaces in the real world. Many robots built for military and industrial and disaster response roles follow the same idea: function first, and adaptability second, and appearance last. A good example is a military robot called the Droid NW40 that was designed for reconnaissance and hazardous operations, and it looks more like a miniature tank than a human. And just like TARS and Case, it's built to be useful with a focus on stability and survivability. When robots are expected to work in dangerous places, a humanoid form becomes less of an advantage and more of a constraint. But here's what makes TARS actually special. And it's not just the design, it's the personality settings. There's this scene early in the movie where Cooper is testing TARS and he asks the robot to set its humor to 75%. And TARS responds with this perfectly timed sarcastic remark that gets a laugh. And what's brilliant about this is that it shows you immediately that TARS isn't pretending to be human. It's just being useful in a way that includes making the crew feel comfortable. The robot has adjustable settings for humor and honesty, which means it can be programmed to lie if the situation requires it, or to tell the absolute truth even when it's uncomfortable. And this is such a smart detail because it removes the mystery about whether the robot is being genuine or not. You know exactly what you're getting because the settings are transparent. And that transparency creates trust in a way that a robot trying to act naturally human never could. There's another moment where TARS sacrifices itself to collect data that could save the mission, and it does this without any dramatic speech or emotional display. It just calculates that this is the logical choice and executes the plan, and somehow that makes it feel more heroic than if it had been programmed to express fear or sadness. And throughout the entire movie, Cooper trusts TARS more than he trusts some of the human crew members, and that trust is built on predictability and competence, not on the robot trying to be his friend. TARS does its job well and communicates clearly, and doesn't pretend to care about things it doesn't actually care about, and that honesty is what makes it feel real. When robots try too hard. Now let's compare that to what's happening with AI and robotics right now. Tesla is building a humanoid robot called Optimus that's designed to look like a person and walk on two legs. Boston Dynamics has Atlas, which can do backflips and parkour, and move in ways that are genuinely impressive from an engineering standpoint. And there are dozens of other companies working on humanoid robots that are supposed to integrate into human spaces and work alongside people. And the technology is amazing, but there's this persistent problem that the more human these robots look, the more uncomfortable they make people feel. This is the uncanny valley, a term coined by Japanese roboticist Masahiro Mori in 1970 to describe the phenomenon where human replicas that are almost but not quite human trigger feelings of unease. The theory is that as robots get closer to looking exactly like us, our affinity for them increases. But there's this valley right before they achieve perfect realism, where they look human enough to trigger our expectations, but not human enough to meet them. And that gap creates discomfort. We see this with humanoid robots all the time, where their movements are just slightly off, or their facial expressions don't quite match what a real person would do. But it's not just about appearance, it's also about behavior. AI assistants like Siri and Alexa and ChatGPT are designed to sound helpful and friendly, and they use language patterns that are meant to make them seem more human, but they can't actually have preferences or opinions or moods. They're programmed to be consistently pleasant and agreeable, and that consistency is exactly what makes them feel fake. If you ask ChatGPT for its opinion on something, it will give you a balanced response that considers multiple perspectives, and it will never just tell you what it actually thinks, because it doesn't actually think anything. It's designed to be helpful, not to be real. And there's always this disclaimer built into these systems where they remind you that they're just an AI, as if that somehow makes the interaction more honest. But really, it just highlights the fact that you're talking to something that's pretending to be conversational, but doesn't have any actual stake in the conversation. And this is where TARS does something completely different. It never pretends to be human, but it also never apologizes for being a machine. It just exists as what it is, a tool with personality settings that can be adjusted based on what the situation needs. And that transparency about its nature is what makes it trustworthy. Why we trust behavior over appearance. Now here's where the neuroscience gets interesting, because there's actual research that explains why TARS works better than robots that try to look human. Our brains have these things called mirror neurons, which are neurons that fire both when we perform an action and when we observe someone else performing that same action. They're part of how we understand other people's intentions and emotions. But here's the key thing. Mirror neurons respond to behavior, not to appearance. They don't care what something looks like. They care about what it does and how it moves, and whether its actions make sense in context. So when you watch TARS move through the environment and solve problems and interact with the crew, your mirror neurons are picking up on the consistency and logic of its behavior, and that's what makes you feel like you understand it. And this is why we can anthropomorphize almost anything if it behaves in ways that suggest intention and personality. People form emotional attachments to their cars, and their computers, and even their household appliances, not because these things look human, but because they behave in predictable ways that we can relate to. We name our Roombas and apologize to our Alexas when we give them contradictory commands. And that's because our brains are wired to find patterns of behavior and assign meaning to them. There's also this concept called predictable unpredictability, which is that we trust things that are mostly consistent, but occasionally surprising in ways that make sense. This is why we love flawed characters in fiction, people like Tony Soprano or Walter White, who have clear patterns of behavior but can still surprise us with their choices. And TARS has this same quality because of the humor and honesty settings. It's reliably competent at its job, but it can also be sarcastic or blunt or even deceptive if the situation calls for it. And those variations in behavior make it feel more like a person than a robot that's programmed to always respond the same way. So what Christopher Nolan and his team understood is that making something feel human isn't about giving it a human face or a human voice or human movement patterns. It's about giving it behavior that our brains can recognize as consistent and intentional and occasionally surprising, and allowing that behavior to exist without the pretense of being something it's not. What AI companies got wrong. And this is where we start to see that maybe we've been building AI and robotics in the wrong direction. Right now, the dominant approach is to make machines that can replace human labor, which means designing them to look and move and think like humans so they can slot into roles that humans currently fill. The assumption is that the more human a robot is, the more useful it will be. But what if that's backwards? What if the future of robotics isn't about making machines that pretend to be people, but about making machines that are genuinely useful in ways that people aren't, and giving them just enough personality to make them trustworthy without trying to fake a connection that doesn't exist? There was a company called Replica that created an AI companion designed to be your friend, and people did form deep attachments to their Replica AIs. But then the company started adding restrictions and guardrails, and users felt betrayed because the thing they thought was their friend suddenly changed its behavior. And this is the problem with trying to make AI that feels like a real relationship, which is that it can't ever be a real relationship because there's no genuine reciprocity. But then you have something like character AI, where you can interact with AI characters that have specific personalities, and people spend hours talking to these characters not because they think they're real, but because they're useful and entertaining in specific ways. The AI isn't pretending to be your friend, it's just being a character you can interact with. And that honesty about what it is makes the interaction more satisfying. And this is closer to what TARS does. It's not trying to be Cooper's friend, it's trying to be a useful teammate with enough personality to make working together efficient and occasionally enjoyable. And that's a much more achievable and honest goal than trying to create a machine that can replace human companionship. What would it look like if we actually designed AI with TARS-style transparency? Imagine if your AI assistant had adjustable settings like TARS does, where you could set how formal or casual it is, how much it explains its reasoning versus just giving you answers, how much it pushes back on your requests versus just complying. And imagine if those settings were visible and adjustable, so you always knew exactly what kind of interaction you were getting. Machines that don't pretend. And maybe the future of robotics looks less like Tesla's Optimus trying to move like a person, and more like functional designs that prioritize capability over appearance, with just enough behavioral personality to make them trustworthy without crossing into the uncanny valley. Robots that roll instead of walk, that use multiple appendages instead of trying to mimic human hands, that communicate clearly about what they can and can't do instead of trying to seem more capable than they are. Because the lesson from TARS isn't that robots should be rectangular blocks, it's that robots should be honest about what they are and designed for what they need to do. And that transparency is what creates trust. And maybe that's the future we actually need, not robots that pretend to be human, but machines that are genuinely useful and trustworthy in their own right. So here's what Christopher Nolan understood that a lot of people building AI today seem to have missed. You don't make something feel real by making it look real. You make it feel real by making it behave in ways that are consistent and transparent and occasionally surprising. TARS feels more human than humanoid robots, not despite being a rectangular block, but because being a rectangular block removes all the expectations and pressure to be something it's not. And that's why a machine with adjustable sarcasm settings and no face can make you care about it more than an AI that's desperately trying to be your friend. Because we don't actually want machines that pretend to understand us. We want machines that are genuinely useful and honest about their limitations. And maybe the solution to building better AI was sitting there in a science fiction movie from 2014 all along. We just needed to pay attention to what made it work. So, would you trust a robot that looks like Tars? Or would you rather have one that looks human? Let me know in the comments. And if you enjoyed this video, hit that like button and share it with someone who loves Interstellar. Thanks for watching. Thanks for